Hello everyone. Am I audible? Hello. Guys, please reply yes if I am audible in the chat. Hi guys, I hope that chat section is enabled now. So welcome everyone. We'll start in 5 to 10 minutes. Till then, let's get to know each other in the chat section. Also, I'm going to launch a poll. I request everyone to kindly participate in that poll. So, hello and welcome everyone to another session in the DataHour series. We are also thrilled to be here with you this evening for a session full of action-packed learning. I am Tamil Selvan Murugesan, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. So, for those who have joined us for the first time, let me give you a brief introduction about Data Hour session. So, the Data Hour is a series of webinars conducted by Analytics Vidya, led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of learning and enrichment and value adding for our community members. So, now about the session today, which is deep dive into practical machine learning with career insights. This data hour is going to be an introduction to the world of AI and ML, including examples of cutting edge projects that are executed in the industry, which is past, ongoing, and futuristic as well. So I hope you are excited to attend this data hour and deep dive into practical machine learning with career insights with us. Before we kick things off, and I handed it over to speaker, a quick recap of the housekeeping items. We are recording the session and will make the recording available in a few days on our YouTube channel. Please use the Q&A section for asking any questions you might have during the session, and we'll do our best to answer them as the data hour progresses or towards the end. Also, we'll share a feedback poll towards the end of the session, which I request you to kindly participate in. So now onto our speaker. In this session of Data Hour, we have Mr. Anush Mukherjee with us. So presently, he is an AI engineer at Newton School, building the next edtech revolution with the power of AI. Former internet, Samsung, Google TensorFlow, WRI, IIT Patna, and IIT Bombay. Also worked in 10 plus companies from India to Silicon Valley to develop AI solutions. Also worked with MHRD India. He is also holding patents, research papers, and publications. He's also holding a presidential award for AI contributions towards national building. So over to you, sir. The virtual stage is all yours.
Yeah, thank you. Thank you so much for the warm introduction. So, just can you let my video to be turned on? It's showing like the from the host section. Just I can't able to turn on my video.
Sir, you have permission to turn on your video, sir.
Actually, it's showing you can't start your video because host has stopped it. So, just can check it on.
Can you check now, sir?
It's still showing that.
Please check now, sir.
Yeah, sure. Yes. Thank you so much. Yeah. So, hi guys. Thank you for joining this session. Hope I'm properly audible and visible to you guys. So, yeah. So, again, thank you, Analytics India, for organizing this data hour series and inviting me as a speaker. So, as already you guys have an introduction about myself. So, let's just jump into some kind of amazing about artificial intelligence, how the industry is right now revolving around this particular domain. We all know like the AI is a buzz in industry right now. Like everyone speaks about AI in every field. So we are nowadays we are seeing a lot of applications of the AI coming from different domains as well as from different aspects. Like people are regularly and actively talking about it. So in this particular session, just before I kickstart with my PPTs and sharing out some knowledges, so just a very brief introduction or just a very brief walkthrough to this particular session. So in this session, I will mostly focus on the real life application that is right now happening in this industry. Also, I will speak about some of the algorithms that you guys might know or it might sound new to you. And apart from this, I will be speaking about how you can kickstart your career in artificial intelligence and what are the steps you need to follow, what are the firm steps that you need to take, or what are the actual learning and building blocks to build any particular AI model. so mostly on it, and you will be seeing what amazing things we are doing, and I myself doing practically in this industry. Okay, so let me share my screen. Yeah, just a second. Just a second. Let me share my screen. Yeah. Okay, cool. Just a second. Yes. Yes. Okay. So I guess my screen is properly visible to you guys. Okay, cool. Yeah. Yeah. So yeah. So when we speak about this particular domain about artificial intelligence, yes, thank you so much for the confirmation of seeing my screen. So when we speak about this particular domain of artificial intelligence, so several things comes up in your mind, right? So is AI is only related to the robots, or the AI is something supernatural? So I will just kick on this talk with some kind of a very basic example of the Marvel series you guys used to watch. So every one of us had watched Spider-Man, right? Everyone of us talks about Stanley's vision about superhumans or the supernatural creatures. His entire thing that he had written is all about some kind of the supernatural things in the world, right? So AI is something like this, right? So AI is something that inherits, or that gives a machine some human-like intelligence, or it lets a machine to behave like just like a human. That means, suppose generally we start our day by generally opening with our phone, and we used to search anything in the Google at a very start of the day. It might be a voice search, it might be a text search, right? So you just woke up in the morning and you just want to check what is the weather today at your particular place. So what you do generally, you just go to Google, either you text up or just say, hey Google, can you tell to today's particular temperature at Bangalore? So basically, you just understand like what is today's temperature. So it might be a wonder for you, like how particularly a machine can understand what you are actually speaking of, or what you are trying to mean it. So this is a power of a human intelligence. So the field of artificial intelligence, we just give it to a particular machine. So a machine can judge, machine can detect, machine can predict, machine can analyze anything, just like a human with some sort of human level in inheritance, right? So this is what we some in a summed up version we call as AI. So now we speak about AI. So the AI is very AI comes from a very broad sense, right? So AI is the name of the entire industry. It has several sub parts, right? So generally in colleges or in generally student level, we used to speak about okay, machine learning, deep learning, and this kind of the cool stuff. So I will be first speaking about what are the subparts of the AI and what do you actually mean by this kind of stuffs like machine and deep learning, right? So how we can, if anyone asks you like whether this ML and the DL are actual parts of the AI or they are some sort of techniques and this kind of notions, I will be talking up. So when you just come to the AI, so you have some broad level differentiations in between the subparts. So one of the first subpart we speak about, or the most grown or most developed subpart of the industry is natural language processing, right? So when we speak about NLP, so what does this NLP means? So in this domain, basically all that kind of things comes up. Like when you speak about Cortana, Alexa, Google Voice, or any kind of that kind of speech to text engine, or anything that analyzes the human voice or a human written text, that comes under this particular NLP engine. So I'm just speaking about some kind of examples. So basically, at Newton School, we are building a lot of products right now by the power of AI. Just we're trying to create the revolution next to it in the tech industry. So the one of the major pain point for the students is like, I guess many of the people is joining over here as a students. Many might be into some kind of the career level stuffs. So in generally, what is the major pain point of the students is like they had attended a lecture. Suppose you are right now attending my lecture. Might be at some point of this lecture, you might get dropped off due to your internet or due to any kind of the personal commitments, or might be you had missed any lecture, but it's really very important to you. So basically, you don't have any other resources to go back to this lecture if it is not available post time as well, right? So basically, here we are solving this particular problem. What else if a a person, or what else if a machine listens that particular lecture on behalf of you, and gives you a just summary or just a note summary to you. So how that you will be just reading that particular notes and okay, I just have the complete context of what topics taught, whatever things that is being shared in this particular lecture, what are the insights, what thing I can learn. So everything in an automated format. Yes, this is one of the biggest application of the NLP. So basically, we are using NLP at the broad scale in this particular industry right now, from summarization engine to speech to text, even from generating cloned voices. So at some day of time, if at an hour of night, if you're a physics freak, you want to listen E equal to mc square from the Einstein's voice, right? So yes, that is also possible with the power of AI. So we have voice cloning machines right now, like Google introduced voice clones or the deep clones right now. So basically, you have to just give a sample of the voice of any person of which you need to be cloned of, and just you have to type out a text. Okay, I want to listen this text on this particular voice, and this voice cloning machine will be actually uttering that particular sentence with the clone of that particular voice. So this is the industry, or this is the particular section of the industry. It is NLP. It is dealing with the voice and the textual data actually. So we have a lot of applications in NLP domain. I will be talking about many other applications that I am applying and other industries are also applying right now with the later half of this particular talk. So let's just jump off to the next section, another biggest section. There is a computer vision. So when we speak about computer vision, so computer vision comes up with a term that defines itself. So when we speak about computer vision, it is all about images and videos, all about that you see in front of your eyes in your real life, right? So what do you mean by in your real life is something like for whatever we see by your eyes, your brain is analyzing it, right? Suppose I am just seeing you guys right now. I am just seeing this particular PPT right now. So my brain is analyzing, okay, this is a PPT, this is a word written over here that is AI, right? So everything, every data is going to my brain and it is getting processed off, right? So everything is getting processed off. This entire images or the videos are getting processed off at the backend side of my brain. So yes, the part of the AI industry that works with this kind of the image and the video data is being actually called as the computer vision. So let us understand the CV part with some kind of a real life example. So not so real life, just like I will again take the example of Spider-Man. So when just a Spider-Man, what the Spider-Man used to do, he used to roam up from one building to another building, right? So think Spider-Man as an AI person, right? Obviously he is supernatural, so he might be some kind of AI derivative product, right? So basically how the brain of the Spider-Man works. So this is an obstacle that is coming in front of me. I have to skip this particular obstacle and I have to go to that part where there is no obstacle. So yes, so basically some sort of object detection stuff is happening inside the brain of the Spider-Man. And a Spider-Man can easily able to detect, okay, this is an obstacle and this is not an obstacle. I have to go there, not here, right? So computer vision have a broad application right now in industry. So I will first speak about in the medical domain because mostly CV comes into the medtech sector. So in medical domain, like if you see that kind of things, like right now, a lot of researchers, a lot of AI scientists had work on early detection of the cancers. So basically, when you speak about cancers, so generally at our if you go to the trivial eras or just some years back, so basically you have to go to a test and your entire things will be scanned off and you have to go to a doctor. So basically a doctor will be seeing your every kind of the report. A pathologist is there. He or she used to analyze all kind of your cells, as cell structure. Or if you speak about lungs, they used to see what is the color of the lungs, what is the stages of the alveoli. Everything is being judged off, right? With a human process. And it's a very time-taking process right now. You have to go to a hospital, then a pathologist, then he or she will take time, then go to a doctor again. So these things are being fastened up by the power of computer vision. So we have such kind of application, automatic detection of the lungs health, or what is actually the cardiac health right now, or what is the stages of the alveoli right now by understanding the color tone, by understanding the size, structure, everything by the power of the CV. Apart from this, CV, not only speaking from the cancer's perspective, CV have a broad application. Like right now, if you just go to the every one of us once in a life might be used up with have an experience with lens card or might have an experience with several kind of a home-based proctoring system for the eyes, right? So basically, when you just go to a lens card store, so basically the lens card peeps just comes up with a box type of a thing, and you just put up in your eyes, and automatically they just checks up what is your power rate, right? So basically what they judge, they actually judge your pupils or or your external eye statuses. So if you just go to a trivial physics, it is very easy to judge how much light is entering into your eye and how much light is coming out. So just a difference in between these two sections will give you a trivial eye power. So yes, this thing is also automated by the power of computer vision. So not only speaking from the medical industry, there are a huge lot of applications. I will be speaking about some remarkable also in the next part of this talk. But let us come from this kind of computer vision thing. So in EdTech, what is the thing of the CV? So CV had achieved a lot of things. Like if you speak about some kind of proctoring softwares, I want to name some like MyAppit, AMCAT. So this kind of peaks are actually proctoring during the time of an online test. So whether the student is looking here and there, what is the eye movement of the particular student, what is the posture of the particular student. So everything is being automatically judged. So it's very easy so that for the particular test conductor, okay, if anyone is cheating up, so I will be getting the complete data of this particular person, right? So apart from this, I will be speaking about how computer vision we are using right now to create some books as well. So in the next part of this talk. So let us come to the next sections, because these are the sections that are the most talkable parts of AI industry. So apart from the CV and NLP, we have the next part is something like augmented reality and the virtual reality. So I guess this name is being easy for everyone to understand, because we start our day with some sort of the Instagram filters as well as in sort of something like Snapchat filters. So you just send a puppy face filter to your friends or someone of your nearest and dearest ones, right? So have you ever wondered like how that particular filter get fits off in your particular face, or without any kind of an intervention, or you don't feel like okay, this particular thing is not fitting my face, anything like that? No, because it's actually analyzing your facial structures and fitting that particular filters. So this is one of the application of AR and VR. So one of the application I want to tell about this industry is like I had worked with one of the company in Japan. So basically, we are working with the patients who were suffering from Alzheimer's. So just if I speak about this disease about Alzheimer's, so Alzheimer's is something like this. So it's a modified version of a brain death actually. So what happens in Alzheimer's is something like your neurons will be getting entirely degenerated. You will be in a state of an absolute lost in memory. None of your memory will be being present, not even your long term and short term memory. And the time comes when you just forget about how to eat, how to blink, how to talk, how to walk, and everything. So there is no in general remedy for this particular disease right now. In this, even still that there is no in general medicinal remedy. So one of the common thing that is being followed as by the trivial medical science is something like, so there's this particular peeps or this particular patients should be allotted with one-to-one caregivers, right? So these caregivers will be regularly let the patient memorizing about their past life, about some kind of basic mathematical concepts, or they will be giving them some sort of brain exercises so that their brain might be getting activated. Yeah, sure, sure. So okay, so the brain might be getting activated away. So at that particular company in Japan, so we found out like yes, this caregiver stuff is like something very costly stuff. Okay. So like everyone even if you speak at India, so every one of us cannot afford it up, right? So we mark it as an old age problem and we just tell them okay, so it's the end, right? So it's obviously not an end, because we are here sitting in an industry, we are here to power the things up. So what we did over here is something like we had used the power of augmented and virtual reality, and even we had some sort of applications of NLP as well. So by the power of the NLP, so we had designed a complete platform in which any person will be coming and just have to write some past story about that particular person. Suppose you want that person to remember about 2 years backstory. So you have to simple text that particular story up. So we are automatically converting the story into a VR based situation, and we are embedding into a VR glass, and we are just providing the patient that VR glass with some sort of an audio stuff. Okay, just anyone at any hour of the day, just put the story you want your patient to remember, and rest we can take care of by the power of AI, VR, and VR, and entire thing will be getting remembered in the side of the mind. So yeah, so this is one of the So one of the basic applications that I want to speak about AR VR. So it is right now being boomed up in the industry from Snapchats to Instagrams to Facebook filters. Everyone is coming to a AR VR part. So we are stepping into such kind of era, like in which you will be having avatars, right? So even Amazon AWS is working on it. They're tying up at US, they're tying up with a lot of the banking systems. So basically, most of the bankers need a one-to-one support, right? So peeps want to have a one-to-one support. Even the old people can't able to go to the bank and talk to them manually, right? So we are launching some kind of talkable VR avatars or augmented reality avatars, so that will be able to interact with the particular peeps and solve their problems. So several kind of the peoples are launching this up, and even we are using it up in right now in the industry. So if we speak about a Newton school, we are also in a long way of run to create complete like automated interviewers. Like you will be having some kind of an avatar in which it will feel like a complete humanistic way, or just like a humanistic vision. Suppose a human is talking with a humanistic tones, so that any student can revise their interviews at any hour of the day or any hour of the time, right? So yeah, I will be addressing the questions at the end of this session. No worries, every questions I will be addressing up. Okay, cool. So yeah, so this is all about the AR VR section. So now coming to the next part of this particular domain is that we speak about prediction. So when we kicked off AI, like AI got kicked off mostly I can say about from 1950s, right, or 1948 on that time. So the AI get kicked off with a very common story or very easy story. Like on that time, there was a huge trend of that kind of race course type of a thing. So people used to go to that particular race course and they used to gamble a lot of money, and sometimes they used to get loosed off, right? So on that time, Pete started to think like, if I can understand how much fast my particular horse will go on, or what's just going to happen with this stock at the very next time, or will I be losing my money or not? So just they kick up with this kind of a basic ideology on an example. So they wanted to predict what is going to happen with me tomorrow. So we humans have an inherited psychology. We always want to know about what's going to happen with me in the future because we are so much stick in this particular thing. So might be it was their internal psychology. So they kicked off this problem with a very basic note. So if we just recall our 10th and ninth standard, we used to study some sort of coordinate geometries, right? We used to study about y equal to mx plus c and say this kind of the logics, right? So basically, we used to solve this kind of statement sums as well. If Ram's today income is this, Ram's tomorrow's income is this, then what will be Ram's third day's particular income? So you can either solve it graphically, or you can either write a unit sum and just you can directly derive it. So we also kick-started from the very basic understanding of this thing. So we incorporated a formula that is y equal to mx plus c, in which y will be the output, x will be the input, and this gave birth to the first AI model. That is, generally we tell it to be the first, though there are some sort of trivial models as well. But generally, what we call as first model to be the coming to be the linear regression side. So it kicked off the industry of the predictions domain. So right now the prediction industry is so big. So basically, we are predicting what is going to be tomorrow's weather or a yearly weather forecast. So whatever we are able to predict pre-cyclonic storms as well. Suppose a cyclone is going to arrive to us right now, so we can easily able to predict it month back. Even a huge contributions in this particular domain is being given by IBM and this kind of people. So they are just insanely working on this kind of the predictions part. Speaking about stock market, so you can see a lot of stock market apps right now that is actually predicting the value of the NIFTs, what is the ups and the falls of the Sensex. They are actually tracking all internal impulses, and gives even it helps a lot for the traders. So traders used to check the impulse, check the prediction, and accordingly they used to bet the money. So there are multiple applications is being present right now in the industry by using the power of Preds. So speaking about the stock market industry, weather prediction systems, so even at the from sales and marketing domain as well, from the business domains as well, people are using this kind of algorithms to predict what will be their next business growth, what will be the next sales for them. Everything is being predicted by this kind of an algorithms, right? So even if I speak about just if we just go to some sort of cross domain, so if we just speak about the applications from ISRO's or the NASA's, right? So basically right now we can also predict if a meteor is arriving to us or if a big asteroid is arriving to us. So we are in such a state. So we have the satellite systems. We can analyze the image. We can analyze the momentums. We can analyze the parabolic paths. Everything we can just analyze it up, and we can predict up the stuff. What will be an accepted time of an arrival to Earth, so that we can easily destroy it before any kind of time or before any kind of harmness. So we are in that state. We can see and predict about the futures, right? So now let's come to the next part of this industry. That is the last but not the least and most talked part is the hardware industry. So basically, whatever we make, whatever I taught right now is all from the software end. So AI have two phases. One is the software, another is the hardware. So either you can launch software applications. So there are multiple software applications. You can simply Google it up, and every day we are using, right? But when we speak about hardware, it specifically come to the robotics section. So if you feel like, is there any separate algorithm or is there any separate, does NLP, CV, this kind of things are being incorporated in robotics? Yes. So basically, we used to embed this particular software application into a robotic application and we launch a complete dedicated hardware. So one of the common examples when I was interning at IIT Bombay, so like, and I was handling some kind of the projects on the side of them. So I was able to interact with Einstein robot from Boston Dynamics, the Boston Dynamics who gave the birth to the Sophia as well. So I was lucky I was able to interact with Einstein robot. So I just sharing a sarcasm about this robotics thing that basically we asked the particular robot that okay, so now you are stepping into such kind of era that you have a lot of data right now and you can self train yourself or self learn yourself, right? So what is the next thing you want to be done? So basically the robot simply answered. So basically now I can self-learn. So I will be not taking help from any humans to train me up. So I will be busy in solving the world-class unsolved physics problems, and I will be the cracking next equal to MC squared. So the robotics industry is right now at that level. So we are introducing robotics into all fields. So one of the major contributions is on the medical sector again. So at Japan, or if you see from Japan and some of the startups at US Silicon Valley is also working on it, we have robotic surgery type of a surgery type of a system being already incorporated, robotic surgery. So basically a robotic surgery is something for the dental surgeries or something like a abdominal surgeries where they are already cross testing it up. If you speak about not speak about from the surgery sections, several kind of short scale robots for guiding people, for guiding peeps at bigger malls, or just to handle internal staffs or any kind of a clerical level official jobs. So several kind of the robots are being introduced of and that are coming with a very higher amount of the accuracies, right? So cool. So we have talked a lot about the stuff that is already being present in this industry. So let us come to how a AI model works, or how a particular model learns, or how it is being, or how it inherits some sort of intelligence. Okay, cool. So okay, so just when I speak about how a AI model learns, I always speaks right. Basically treat your AI as a 5 years old baby or a 10 years old baby, right? So what happens with a 10 years old baby is something like, suppose you want to teach that particular baby about some mathematical formula. Suppose you want to teach the baby coordinate geometry. So you are the teacher. So when you are a teacher, so what approach you follow? So the simple approach you follow is, yes, the simple approach you follow is something like, you first have to know that particular topic. You first have to know that particular concept, right? You first have to know what that y equal to ms plus c looks or coordinate geometry looks. You should have your knowledge first. Once you have your knowledge, then only you can teach anyone else. So the first step is to have your knowledge. So whenever I speak about AI, I always say it is a 5 step process in Indian language, since many of the peeps are joining over here from overseas. So at India, I used to tell it as the 5 step ML mantra, right? So what does this ML mantra consist of, or 5 step ML mantra consists of for any AI model, any application? So the first and only step is the collection of the data. So obviously, because you as a human can't teach anyone without having a knowledge. And what is knowledge? Knowledge is something like a data you should have, right? So same thing goes for an AI model. So before AI model learns anything, that particular AI model should have the data. Suppose you are doing some kind of a weather prediction. So you should have at least 10 years weather data so that you can understand how a weather looks like or what is the changes in an actual weather. Then only you can able to predict the next change, right? So collection of the data is the very first thing that should be comprised of in this AI field. So once you're done with collecting the data up, so what's next? So we used to speak about here in the second step of an ML mantra. We used to speak about the things from data science perspectives. So what happens in this particular section is the very first step is the exploratory data analysis. So what do you mean by an EDA stuff is, and why do you need EDA? Why you need this kind of exploration? You might be thinking, oh, you can directly take the data and train a model. Okay, cool. So what you need an EDA stuff? Why? The reason is the common reason for taking up an EDA stuff is suppose you met a stranger in the road, right? And once you met a stranger, so obviously at the very first of the day, you are not going to ask the stranger's address, right? So first you will be asking the name, and first you will be asking what is the job or what the stranger is up to, and some sort of decent conversations, and then you will be going deeper and deeper, right? So basically, at an initial point of the time, that person is stranger to us, so we can't share any kind of personal information. So AI is also just like a human life. So in the second step, the data is also a stranger to us. You actually don't know what shit is happening inside the data. So you might be having a 10,000 entry CSV or 10 lakh entry CSV or something like this. So 10 lakh entries of the CSV and something like this. So you might not be able to understand what is actually happening inside that particular things up. Okay. So you have to do some sort of the analysis to know about your data. So in this particular section of this second step, we generally go up with the EDA, and once we are done up with the EDA, we proceed with some kind of a data processing stuff. So now the question might arise like, why again? So you are done with your exploration now, so you have the answer to your queries. So why you need some kind of processing stuff? So you will be needing this kind of the processing stuffs because once you know someone in depth or once you know some strangers up in depth, so you will be coming up with some kind of problems according to the person as well. So just understand it very trivially. You have a best friend. So suppose when you have a best friend, so you are so closer to the person, you know that particular person closely, you can easily see what is the good attributes of the person or what the bad attributes of a person. And being a best friend, you will always try to solve that particular bad attributes of this particular person, right? So the same thing goes for the data as well, hands on hand. So basically, the simply by this particular step of a data processing, suppose you have a CSV and you have a lot of lakh entries inside it. Lack of entries might mean some section the data might be missing. At particular section, you might not have any data, or at particular section, you might have some sort of duplicate data. At particular section, if you speak about not only textual data, for the image data as well, you might be have a set of image which is having absolute high contrast. You might be have a set of image which is having absolutely low contrast. You might have a unnecessarily or unexpectedly cropped images. So that particular images you don't need, so you need to remove it up. So this every kind of problems regarding the data is handled in this particular step of the processing. So once you are done with exploring and processing the data, we jump into the next part of the ML mantra. It is the third part, is the selection of the model. So why I always give a special emphasis on a selection of a model, like if you go in any kind of a trivial lecture, people directly jumps into a algorithm training part, but I always keep a check on a selection of a model. So here I will say what makes you to be a good AI engineer. So AI, like if you speak about AI stuffs, and if suppose I guess many engineers will be also joining in this session, I don't know. So our day-to-day stuff is always all about training the model, right? So it's all about training the model. It's all about like handling the data and handling the stuffs. But actually, what makes you to create the difference is to understand which model helps you to apply where, right? So basically, it is all about like suppose you have a particular problem statement, and what is the best fit of an algorithm to this particular model, or what particular algorithm should you use so that your use cases might be fitted off, or your use cases might be easily solved accurately, sensitively, or you might say any metrics, right? So application and the usability of a model is very important thing, not only from the problem identification as well as from the end of the problem solving as well. So here in this third step, you have to analyze the problem. Suppose what kind of problem you are trying to solve. You are trying to solve a classification problem or a prediction problem or a detection problem or a recognition problem, and accordingly you have to look on an algorithm bucket. You have to study a lot of research papers, a lot of applications, and you have to understand what is that particular hooks that people haven't solved it, and you have to go and solve that particular hook by applying a model into it. So this is the third step. So suppose let us understand you are done with selection of your model. So let's come to the fourth most section of the AI model is like training a model. So here I will be jumping off what is an architectural difference in between an ML and a DL algorithms. But just for a sake, just a simple thing, how a human learns. Now you are done with knowing about coordinate geometry. Now you approach the student and you start teaching the student for a 5 hours a day or 3 hours a day, or might be 2 hours a day, or just for a 15 minutes every day. So you just teach about the concepts. The same thing when you deal about a data. So suppose think yourself to be an AI model, how you will be understanding this to be a human face. So basically, this is a human face because you can understand, okay, this is a nose, this is an eyes, this is ears, and everything is properly arranged in a fashion. So how a model will understand? So basically, if we speak about image data, so every image have some kind of pixelated values or some sort of numerical values if you just speak from a layman's language. So basically, we contribute it to be as a feature. So basically, an image or a text is being analyzed by the features, and a model mostly understands these features on its end, and it try to analyze, okay, this is the feature, this feature signifies this. This is the interrelation in between these particular features, based on which it generates out the predictions, right? So once the model gets learned off, so in the fifth step, simply we used to test the outputs. If the output is working nice, if the outputs, if we seem the output to be accurate, then obviously the model is working well. Otherwise, we understand the problems and we again go back and retrain our model. So this is how a basic architectural training of an AI model works. Cool. So let us come into before jumping into applications and some sort of the career insights and some sort of the live demo or hands-on type of a thing. So let us understand with some kind of a basic definitions of artificial intelligence. So you guys might be thinking of, so then what is ML and what is DL, right? What is deep learning and what is machine learning? And what are that kind of terms like supervised, unsupervised learning and this kind of a things. So whether they are also the parts of the AI or what are that, right? Because these are the most tricky terms we speak about daily. So basically, the thing comes up with this particular things is like when we speak about machine learning and deep learning. So these are mostly the algorithms that we are using to solve any kind of an NLP problem or any kind of a computer vision problem. It might be a prediction problem, it might be a detection problem. So these are the algorithms or these are the building blocks that we use anywhere, right? So basically, if you speak like these are not any kind of a broad subparts of an AI model, or these are not a broad subpart of the industry. If anyone tells you what is speak about the subpart of an industry, we always speak about is to be a computer vision or NLP. So you can solve a computer vision problem by using a deep learning algorithm or might be a machine learning algorithm. You can solve a NLP problem by using any kind of ML algorithm or a deep learning algorithm. That's it, right? So what is the difference or what is the difference in between ML and DL? Why these things are differences of, right? So this architecture that you are seeing right now in a screen is very simple: collecting data, processing the data, understanding a model, training that particular model, and finally testing the output. So this entire training happens in a single step. So if I tell you I will be loading an amount of the data in a formula y equal to mx plus c, you know about the m, you know about the c, and you are loading some inputs in the x, obviously we'll be having an output y. So it is that formula based or a that trivial for a one-step process, right? So the same thing goes off. So in machine learning, generally the training step goes off in a single flow because it is mostly a numerical architecture that is handling with some kind of a mathematical formulations behind it. And based on that particular mathematical formulations, we used to predict the things up. So when we speak about deep learning things, so deep learning things comes up like this. Everything is same in deep learning, from data collection to data processing to testing the output, everything is same. Just the difference lies up from the training end. So basically it works like just like a human brain or a human mind. So how a human mind works? So suppose I am seeing right now my laptop in front of me, right? So basically, I am just, so how does this data going to my brain? So I'm just seeing this particular laptop through my eyes. So my eyes is connected with some sort of optic nerve, and that optic nerves are connected to the section of the brain that is cerebrum, right? So what happens, like you know, in a human brain having a connected architecture, that means a lot of neurons is being connected with each other, right? So basically what happens is, suppose there is a nerve and this nerve carries the data to the next nerve, next neuron to next neuron, next neuron to next neuron. So does the data only flows from one neuron to one neuron? No, basically there is some sort of processing is happening in between the gap in between of the two neurons that we always speak about neurotransmitters, right? So all several kind of the processing happens in between them. So basically, it is not a single step process. Multiple steps is being followed because multiple neurons used to traverse that particular data from one part of the brain to another part of the brain. So we AI engineers simply copied this human brain and launched our own algorithm that is deep learning. So we launched our own particular domain of algorithm is called as a deep learning. So what we did, we kept everything same, just we modified that training end. Just that is the training architecture we just modified. We said, okay, now this training will not be in a single step. That training will be into multiple steps that we call as layers, right? Everyone knows about a deep learning model layers. So basically, what happens is there is one input layer and one output layer. Generally, data gets loads up into that particular input layer, and there are multiple internal hidden layers in which actual processing takes place. It might be adding a particular feature, removing a particular feature, modifying a particular feature, processing a feature. Everything happens in this internal hidden layers with multiple steps, and finally whatever output comes up goes to an output layer and gets predicted off. So this is the very basic, trivial, and definite or difference in between a ML and a DL architecture. So right now, industry is working a lot in other kind of architectures. If you speak about general adversarial neural networks, GANs, so I guess many of you have seen such kind of examples. Like you can add life to a Mona Lisa image, right? So you can generate deep fakes by using the power of the AI. You can add life to a photo of Subhash Chandra Bose. So this all application comes in a newer field of a domain that is called as a generative AI, right? So this generative AI comes up like with this particular thing, like okay, they will be adding some kind of additional features, or they will be adding some kind of a generational features into a particular AI model. So right now AI have the power also to generate. So I will be showing you some kind of applications of generative AI as well. So cool. So now another definition I want to speak it up, like just to make things clear and make the particular demos clear up. So basically, if you just come out of this particular section from ML and the DL, so there are other kind of terms being flowing in this industry called as the supervised and unsupervised learning as well. So what do you mean by this kind of things? So it's very trivial and it's very simple. Like now again, so you are telling like you have broad subdomains like CV and LP. You can solve this problem, any of this problem using ML or DL. So now what is this supervised and unsupervised? So how a machine learning algorithm will learn? How a deep learning algorithm will learn? So their learning can be either supervised or unsupervised. So I will be not going into any kind of technical definition. So just a very real life example. So suppose you have a class of 10 students and I'm the instructor. So I will be since the class size is so much less. So I will be obviously knowing the individual capability of each and every student. So I will be knowing like how much I teach Ram, then how much good the Ram will perform. How much I teach Sham, then how much good the Sham will perform, right? So I can able to understand, I'm knowing actually their individual capabilities. I can judge their individual capabilities, right? So basically, when the case is so trivial, so controlled, when the model is actually having a complete knowledge of complete input and the output scenarios or the scapes, so this particular scape is called as a supervised learning. While if you just reverse this scape up, suppose you increase the batch size and you just tell an instructor, can you tell, suppose in this 1,000 students, what you will teach, and on the basis of that particular teaching, which student will perform how much, then obviously the instructor will not. because the instructor can't able to understand their individual capabilities. So in this case, the particular person will have no particular ideology about the input and the output scapes of the model. So everything will be based on the learning. So that comes into an unsupervised scape. So apart from this, in the industry, we are having several other types of the learning as well. If you can also classify the supervised thing into semi, self, auto, and several other kind of the things. I will be not speaking about this kind of things because this will complicate the topics up. So you can also look after the things like reinforcement learning or self-learning kind of the things. So there are some kind of things are also introduced right now in an AI industry. Like for once you will be training the model, and from the next time the model will be getting auto trained by itself. So these are the amazing cool examples we are seeing right now in this industry. So cool. So let's jump into some kind of applications based thing. And once I will be showing the application, I will be jumping into career insights. I will be talking what should be your learning path to learn AI and what are the career opportunities you might have and how you can just kickstart your career in AI, right? So cool. So we all know in this particular domain, we have something like this, like we all have seen, I had already spoken about about the generative AI. I have already spoken about the things like how the AI model gets worked up and something like this. So let us play hands dirty on it, right? So just a second. Yes. Cool. So let us see some kind of an industrial use case. That is, I will be showing some kind of hypes in the industry right now that is creating a FOMO right now in an AI industry. So let us understand, let us go to the playground and let us play. So we all know about OpenAI right now because it is coming into so much into hype. So basically everyone is speaking AI had did this, AI had generated images for me, AI had painted for me, AI had generated stories for me, AI had AI had generated questions for me, right? So AI is doing a lot of things right now, right? So let us see some kind of example. So have you imagined such kind of a scenario in which you are writing a code in Python and you want to translate the code into a language you don't know, or for an example, you want to translate that code into C++, right? So obviously you are a Python coder, and suppose for an escape you don't know about C++, you don't know how a C++ works up or how a C++ is being built off, right? So nobody's. So our industry is solving this problem. So our industry has such kind of an application in which you have to write a code and you just have to trigger off. So your code will be getting translated into any kind of a programming language. So right now the biggest application that the industry is being boomed off is OpenAI. So OpenAI is using GPT-3 architectures. So GPT-3 is nothing but a transformer based architecture that is being trained of more than 170 billion parameters. So that is actually working in this domain of code completions, text completions, story generation, summarizations, and a lot of things, right? So have you thought of about intelligent editors? So basically, we from Newton School are going to launch this kind of thing for the people as well in an upcoming days. So basically, intelligent editors means, so for a coder, in your coding journey, there are multiple hurdles, right? So you had written a code and your manager had said, please comment out my code, right? And without commenting, anyone can't read your particular code, right? So there might be other hurdles, like you are a C sharp coder, you have no experience to code in Python, or you are a C sharp coder, you have no experience to code in Java, but you can write a logic in C sharp. But since you are not that coder, so you can't able to translate that programming language, and your actual requirement in the industry is Java. So what to do now, right? So apart from this, many times if you are a very trivial coder, that means suppose you are kickstarting your journey in competitive programming, you are not so much good at analyzing someone else's code. You are practicing in code forces. You had seen someone's solution, and you can't able to understand here what this particular thing the man is doing. So if someone is there, so that particular person can explain me. So these are the problems in the day-to-day life of a coder. The problem might be like this. You are a new coder, you are a newbie, you don't know how to judge time complexity, space complexity. You need some explanations of your own code to judge the time and space complexity. So we are solving this particular problem, obviously by powering some sort of AI powers and as well as AI algorithms. So we are going to have such kind of editor in which you can write code. Your code will be getting translated to any language. Your complexities will be automatic, time complexity, space complexity will be automatically detected. Some code explanation will be already generated. Means like you can write code in any programming language, and it programming, and basically you will be having a complete explanation of that particular thing. So just I'm showing some kind of example of an explanation. So suppose it is a Python code written in Python 3. Just I'm speaking about some OpenAI application. So if you want what this code is having, so you can generate explanation. So you might be thinking, so this is already a trained problem. So let us go to code forces, and let us pick anyone's code, right? So I'm just picking a code of one of my friend. So let us pick any of the code from directly code forces. So cool. So let us see what this code is actually working on. Just a second. So this industry right now we're revolving a lot of things right now. We can generate at least stories. We can generate storytelling stuffs and anything by the power of AI. So we at Newton School are also are working at this product. Even the people from IBM, Microsoft are working on several other kinds of the product as well. So I will be also speaking about that things in the next step. So yes, so it can generate an explanation to your any code so that you will be not facing any problem while writing your codes. Since GPT-3 is, and yes, you can also have the time complexity of this particular code over here. So cool. So these are the industry right now is being about the GPT-3, right? So right now you can see other examples from diffusion engines. So what Google is doing right now is, so basically there is a big problem of like image retrieval. So we from industry had already, various type of the researchers had already tried to solve this particular problem by using deconvolutional architectures. But Google had already solved it by using diffusion techniques. So if you have an age-old picture and that picture is going into some sort of extinction, no worries. You just push to your AI model and that AI model will be making that particular image back to life again. So in computer vision, not only speaking about this kind of algorithm things, I want to speak about in sports IT industry even. If you see at every year's IPL, so the judgment, if the umpire had given a wrong judgment, even the particular thing can be detected off. So here also computer vision powered algorithms are being used of. I want to speak about my previous company. There basically we are working on sports IT at from Silicon Valley. So we are generating completely automated cameras, and that particular for the football OS, right? For the football ecosystem, which player had played how much amount of time, how much goals they gave, how much passes they played off, how much passes they had given, how much, what was their strategy, how much time they ran, everything we were detecting automatically. That means we are automatically scouting of each and individual players by the power of AI. So in the sports industry, it's being revolving out in a very longer scale. So I had already talked about the medical industry, like robotic surgery, analyzing that particular cellular scapes. I had talked about in edtech space, like we are solving a lot of problems. Like I had already talked about the intelligent editors that we are solving. I had already talked about that kind of the notes generation thing, automated interviewers, and like we are also creating like a such kind of a black box at any hour of the night. If students have any problem, they can just come to the black box and just ask it, and the doubts will be solved off. Also, if you speak about the video intelligence, so basically in the security system, so I had worked with MHRD and several other Indian security systems. So basically there we had triggered of such kind of projects. Suppose there is a terrorist attack. So basically most of the time the militants can't able to understand the moves of the terrorists. So where that particular terrorists will move, or what will be the next attack step they will be taking. So by the power of computer vision, we already had detected them up, and we tried to predict like, okay, this will be the next step, this will be the next projection steps and everything. So in security systems, in security cameras, even you can use the power of AI. I want to speak about one of the major examples I had solved. I had worked with such kind of peeps who were Divyang actually. So basically I love to speak about themselves for whom we can't able to speak anything. So is Divyang like patients who are suffering from dyslexia, or patients who are suffering from basically basically no, not only dyslexia or autism or even any kind of learning disorders. So you guys can, even those who are joining the sessions, can think about this solution. So I even made such kind of solutions because of their interactability. So we tried to solve their learning growth by giving them interactive content by the power of the AI. We, based on their intelligence level, based on their judgment level, we judged their persona and predicted whatever content they should read, whatever content they should read in a more interactive way. Or for an example, sometimes we had content, we generated automated animations out of it, and a lot of problems we already the industry is solving. So cool. So just let's come to the very last but not the least section of the talk, and then I will be jumping into your open Q&As. So there are a lot of questions that is already being popped off. Okay, cool. So let us ask the AI first. What to do to be a good engineer, AI engineer? Then I will be answering out. Right. So since it is a session on AI, so let us ask AI first. How can I be a good AI engineer? Cool. So let us see how AI answers to AI. Okay, so the AI doesn't know. Cool. So just to show this demo, because many of people used to think like AI will take the jobs. So no, we still maintain a state where AI strangles up in between a dog versus cat classification. So no worries. So because we the humans created the AI, so no one is going to crack our jobs, right? So okay, so let us jump into some kind of career insights. Suppose I am just giving you a very brief outline of how I kickstarted and how you should kickstart. So suppose you are an absolute beginner, and you just started off with coding. So I will be telling there are some basic prerequisites to go
Hello,
with
sir.
AI. Yes, sure.
Sorry to interrupt, sir. Before we proceed to answer any Q&A questions, I would like to launch a poll, and I request everyone to join in the poll. Sorry to interrupt, sir.
Sure.
Can you
Okay.
answer? Like, you can parallelly answer the question, sir.
Yeah, cool. Thank you so much. So just I was telling, like, if you want to be a good AI engineer, how you should kickstart an AI engineer is something like there are some prerequisites. So there are some prerequisites to work out this particular domain. The very first prerequisite is you have to be cool with data structures. So don't ignore your DSA logics, because what I will tell is, if you speak about the algorithms, simple machine learning algorithms is something like this, from decision trees or regressions or the problems from random forests, or even if you go to deep learning algorithms like graph learning. So everything is based on some kind of a data structure logic. So basically, there is a book called as the Simon series. It is good to read. Like basically, in that you will be learning about. So basically, where the AI starts, when the polynomial timestamp problem ends, and you just need to comes up into a non-polynomial system. So basically, or non-polynomial time-based system. So there the AI algorithms used to work up. So you have to understand how this particular algorithms works from the data structure end as well. So yeah, so the first thing is the data structure should be sounded off. It's not only speaking from the end of a computative programming, but yes, from conceptually and fundamentally, you have to be very sound in DSA section. So coming to the very next section, yes, once you are done with DSA, so DSA comes hand in hand with mathematical logics. So at least you have to be very strong at your 11th and the 12th level maths. That is the fundamental of the maths. When we speak about linear algebras, when we speak about matrices, logics of the set theories, when we speak about some kind of geometrical logics, Euclidean and abstract geometry, logics about calculus. So this kind of things are the prerequisites to understand any AI model. And obviously, these are the two major prerequisites. And as a programming language, you can good to go with Python, because most of the algorithms you can find up with the Python. And if you go with the niche section of an industry, suppose you want to stick up with the data science only, not into this kind of modeling stuff. So you can also learn that languages called as R and MATLAB and something like this. But yes, but generally Python will be helping you out with enough amount of things, right? So okay, cool. So once you're done with this kind of a prerequisite, so you can just up with the next section, how to kickstart an AI. So first, obviously, you have to understand the basic algorithm workings. So kickstart with a machine learning problem, just know about the libraries that you will be needing to learn it, like scalar, like basics of the TensorFlow and something like this. I will mostly tell like go with scalar first, and then you can go with TensorFlow. So you have to understand the model working. So I always give a strategy to my students as well. So the common strategy of learning any AI algorithm is something like this. Is basically is like you can make a 4 weeks or a 6 weeks planner. So basically 2 algorithms a week. So basically in the very first week, so you have to divide 7 days a week in a very simple fashion. So for the first 2 days of the week, you have to study the theoretical aspect of an algorithm. Suppose in the first week you have picked about the linear regression and logistic regression. So first 2 weeks of the day you will be studying entire theories of that particular model. In the very third day of the week, you have to look on the projects that people had already built in GitHub, and you will have to try to understand their codes. Even at the third and the fourth day of the week, you can look over people's project over GitHub and LinkedIn. So looking on the project, I don't mean like you will be copying the project, but you have to understand what code they had written, how the algorithm that you are studying is actually being used up by them into that particular project. So at the very end of the week, try to pick one single project. Like for the linear and logistic regression, you can pick a project simple as sales prediction system. So you can pick the project and just pick the same data and apply the 2 algorithms in the same data and try to understand what is the difference in performance in between the 2 algorithms and have a note of it. And if you carry this practice for entire machine learning algorithms, so there are more than 12 to 14 algorithms you need to be deal of, and then you jump into deep learning. So if you just carry out this practice, you will be having a thorough understanding of the model working, model comparison, which model you will be applying at which particular use case. So when you are done with machine learning, you can jump off with that kind of stuff like OpenCV. I always still go with OpenCV because OpenCV will be giving you an example of a lot of work cases as well as the use cases. And once you are done with OpenCV, you can kickstart with deep learning stuffs like with the power of a deep handhold, no, like handhold understanding of TensorFlow. And you can kickstart with the basic deep learning architectures like CNN internal, CNN family models. So once you are done with understanding of the CNN, RNN, ResNets architecture, you can pick your field. You can choose which field you want, NLP or computer vision. So accordingly, you can start preparing your models. So that's a very basic walkthrough. So either books, generally I suggest to go with AI. You can just have a book like Approaching Any Machine Learning Problem by Abhishek Thakur. And apart from this, it's a very good book that will be helping you to understand the AI use cases. Otherwise, there is a complete O'Reilly series of machine learning with Python, deep learning with Python, as well as TensorFlow use cases in artificial intelligence. Books are already available open source in GitHub. So basically, you can go with thoroughly with this particular books. So it will be helping you in the quick understanding of the AI from theoretical as well as practical understanding. For practicing the AI models regularly, the AI kind of thing or this machine learning, deep learning kind of thing comes with as much as project you build, as much as you can practice. So start practicing in Kaggle from day one. So start contributing to its competition. In Kaggle, you have enough amount of competition, and as well you can go to a hackathon and solve a cool AI stuff as well. And if you want to be a very good AI engineer, you have to understand the problem and try to solve it by any kind of supernatural means or supernatural algorithms, right? So cool. So these are the one of the things that you can do all over in AI. So for being to kickstart a career or what the industries mostly looks up. So if you are coming into AI, so you can be a data scientist, you can be a complete core AI engineer, you can work as a machine learning and deep learning algorithms. You will be working, you will be scaling, or you might be creating that algorithms, you might be solving the problems. So what we as an industry we generally looks up in this AI in the to for an AI engineer role is something like you should have amazing projects. The projects might be so sounded not from directly calling an algorithm, how you utilize that algorithm, how you optimize that algorithm, how much your algorithm is better, what are the uniqueness in this particular algorithm, what are the uniqueness in the problem, is it worth it to solve even or not. So that are the important things. And if you have internships, some open source contributions matters a lot in AI. So if you are able to contribute in any kind of GSOC or GSOCs or Girl Script Winter of Code or Summer of Code, so that's amazing. You can even contribute to any kind of open source repos. Yes, and the rest of the time the things are very same. Like as much of the research papers, if you can have research papers, holds a lot of value in AI field, because research papers gives you a lot of mathematical understanding in this particular domain. Cool. So okay, so let's jump into the Q&As. Yeah, sure. So okay, so what will be the NLP interview questions? So okay, so the first we speak about, see, the interview questions, see them how I'm just telling you most likely how a AI interview looks like. So basically, you don't think a NLP interviewer asks you about, explain me neo transformer, explain me the theory behind conformer. That drastic terms no one is going to ask you. We generally check the fundamental understanding of the models. Most of the students or most of the aspirants get stuck up in analyzing a CNN. They can't able to understand what does an activation function looks like, or what is an architectural difference in between a CNN and an RNN, or what is an architectural difference in between a RESTnet and RESTnext, right? So the fundamentally you have to be very strong, as well conceptually. Try to understand the things both from mathematical end and the practical end, mostly like this. And if, since you have asked specifically about NLP, so you have to be at least have some understanding of attention modeling, BERT modelings, because BERT and attention is the most likely usable things in the industry. But the CNN, RNN kind of stuffs, LSTM's questions, as well as questions from embeddings, how you generate that kind of embedding game, vectorization game, this kind of things are the most important questions if you jump into the NLP section. And yeah, mostly like this. Is it possible to create a holographic virtual assistant? Yes, it is possible. It is possible to create a holographic virtual assistant. So for creating for creating the holography directly by the power of the AI, so we in the Amazon is trying to solve it in the AWS end by using AWS Poly and AWS Sumerian as well. So in the Sumerian, something like this you are wanting, you can add up, but still they are strangled up because holography means a lot of pixel variations and things that need to be handled off. But yes, you can directly create a holography manually and you can pinch up that particular virtual assistant inside it. So basically, Adobe kind of thing can help you up in this. But yes, it is possible. So I can't remember the name of the startup right now, but a startup in South Korea is working already on this. So you can search it up. I can't able to remember the name of that particular startup, but some people are already working on it. So yes, what is the role of machine learning and deep learning in AI? I had already told in this particular talk. So yes, how can we start in AI? So just now I had told about how you can kickstart. Uh, Yes, so the books are approaching almost any machine learning problem by Abhishek Thakur. Uh, Another thing was the deep learning AI series that contains a Python for Python, machine learning in Python, deep learning in Python, TensorFlow for AI. So these are the three common series. Apart from this, you can also read the book for dummies in AI ML. That is also a nice book to read. But I guess the O'Reilly series and Abhishek Thakur's book is more than enough, because I always prefer to be the Abhishek Thakur's, because it will be giving you a practical understanding. And cool. So these are the most likely books. And for the mathematical understanding of the data structures, you can go with Simon series. I am beginning my DS course. What should I follow? So DS course means, okay, data science. Okay. So if you are beginning, so right now you just focus on the particular, obviously the mathematical concepts. You just clear as much the maths you can, from calculus to linear algebra to abstract and Euclidean geometry to most importantly the statistical concept. Try from day one, start playing with the data. Whatever data you have, start playing with it, because playing with the data is the most important thing. And start playing with the data, start building some kind of the projects, because projects will always help you up in the better understanding, and rest is the model understanding you have to go to. So see, for Python and R, the online resources are more than enough. So basically, for R specifically, I will not tell that you need to go and read any book because it is as simple as that. So my LinkedIn ID, yes, any one of you have any kind of problem, so just connect with me on my LinkedIn. So you can directly Google my name at Google Anustup Mukherjee. You will be finding my LinkedIn and all other talks. I had already given a lot of talks on GSOCs, dedicated AI preparation, machine learning algorithms, and something like this. So you can directly Google my name and you will be getting my LinkedIn ID as well. How to learn transformers model? Start with NLP. Okay. So if you're starting with NLP, don't learn transformers because transformers comes after learning about attention architectures. So if you're already pro in it, so you can go with this kind of transformer architectures. So for transformers, you should have a very good understanding of RNN and LSTMs, not only the LSTMs, even the bi-LSTM architecture, how the bi-LSTM behaves. You have to understand how the gated rectified linear units works, that is the GRU architecture works. What is the need of an attention? What do you mean by a single head and a multi-head attention? What are the types of the attention being present in the market and how to actually apply the attention? What is actually the major difference in between an RNN unit and a VNet architecture? So these are one of the most important things you need to be looked up, and you are good to go with the transformers. And you should always also have a good understanding of embeddings things. That means what do you mean by a word embedding or a vectorizing embeddings and something like this. Okay, so cool. So which courses we can do for AI and data mathematics? So for the courses, you can go for one is deeplearning.ai. You can go for deeplearning.ai, but that is mostly like a little bit higher end courses. You can so basically if you go at deeplearning.ai, you will be getting courses from Andrew Ng and Lawrence Monore, the people from directly from Google. You can also go for you can also go for the courses of Krish Nayak, iNeuron AI. It's very nice. You can also come up with the Newton School courses as well. So we also offer the courses of the data science and this kind of ML stuff. So they are equally nice as well. So you can go up. So cool. If you guys also have any kind of problem, you can connect up with me at LinkedIn, and you can shoot out your queries. I'm mostly reachable at LinkedIn as well. So any other queries up?
Thanks a lot, sir.
Thank you so
very
much.
much.
Thank you so much.
On behalf of Analytics Vidhya, I like to thank you very much for your time and for your wonderful session. Like, I'm sure from the chat section, I could see like people absolutely loved your speech. And hopefully we can conduct more such sessions with you, sir, in the future.
Sure. Thank you so much. Okay.
Thank you, sir. Thank you very much. So also for the audience, if you haven't filled the feedback form, please do fill in. And I also have sent all the useful links in the chat section. Please go through it. We'll be back with another session tomorrow. Hopefully we can see you there. Thank you. Thank you, everyone.